Cheers. Hi guys, welcome back. We're now entering the game flow section of this course, in which we're going to be tackling a couple of things. First, the cameras. So moving cameras in between different state of the game. That's also going to be a big concept. One of the big reasons why we're having this right after the player is because we're going to have a very similar system driving our game. So another very small this time, a state machine that is very small, but it's going to tackle a couple of things. So I'll give you an example. There is a state where we're playing the game right now, but there's also a state where we're idle at the beginning of the game, where you get to choose if you want to start playing or go to the shop. There's going to be a state for the shop. There's going to be a state for when you're dead. All this kind of good stuff. So um, going forward, we're going to try and make the video as small as possible because there's not going to be so much content, but everything that we do is going to be compounding. So it's going to be something that you must not miss, and you got to be very careful. So what I'll attempt to do, and I do invite you to check as well, is every time we do a change towards the end of the video, we're always going to be testing the game. And if you're not getting the same behavior as I do, it might be worth rewatching a short video. Now, that being said, most of the work we're going to be doing in this section is going to be in the same folder for scripting. So if we head over to scripting, we're going to create a new folder and call it game flow. Oops, there we go. And we can go ahead and right click, create the first script, which is going to be a game manager. Now, do note that once we create a game manager, you're going to see a different icon. This is a .cs script, a normal script, just like all the other script we've made. But it's something that is built in the engine in Unity that when you call a script game manager, it's going to end up having this little gear here. Don't worry so much about it. There's no change. It's the exact same thing as before. It's just known practice that sometime you have a script that is called game manager, and it's a neat little addition to see that this is kind of a recurring thing. So it's recurring so often in so many different games that they just made an override for that icon, which is a neat little touch. And beneath that folder, I'll create another folder called state, or you can call it game state. And I'm going to create another .cs script and call it game state as well. So we have two new scripts. One of them is called the game manager, and the other one is the game state. I'm going to start with the game state. We're going to go and lay down a state machine just like we've did for a player. So something very simple that has three things: construct, destruct, and also some sort of transition. So let's try to do it quickly. I'm going to remove these two at the top. This is going to be a abstract class, so you can't just spawn it on its own. And it's going to have a public virtual void construct. I'll copy this over. It's also going to have a destruct and also a update. So destruct. And we called it transition for the previous one. Here, I'll just call it update state. So it's something that's going to be called every single frame. And then at the top here, I'll do a private void awake, and we'll get a reference to our game manager. So the person who's going to be controlling the state in this case, or the whole state machine, is going to be the game manager itself. So do remember here, on our player, it's the player motor that has a reference to the base state. Actually, for the game states, it's going to be the game manager that has a reference to these, and we'll do a two-way reference here. So if I go to the top, I'm going to create a protected game manager, call it the brain, or yeah, call it brain actually. Yeah, it looks quite cool. And I'll say brain is equal to get component type of game manager. Okay, now with that in mind, we can close this one off. We're actually done with this script for pretty much forever because it's the base script. So I'll close this off, and I'll actually go and create a new object in my scene. Call it the game manager. Maybe you want to give it a certain color as well. So maybe a yellow, like so. And I'll add the game manager script to it, just like so. And that's where we're going to leave things for now. I just want you guys to understand that we are starting another state machine pattern in another object that is very similar to what we've done, but this time it's going to be controlling the state of the whole game. We used to controlling the movement. Now we control the state of the game. Do note that a state machine could be used to control the behavior of a certain boss with some logic behind it. It could be used in a lot of different contexts, and here we'll be using to wrap our whole application around it. So I'll see you in the next one, in which we're going to start coding our very first game state. In this video, we're going to be tackling our very first state for the game. The video is actually going to be a bit longer than the rest of the other states, simply because we have to lay down the groundwork on the game manager to switch in between state and also to make sure we can call it from different places. So we are actually going to start this off not by creating the state, but by opening up the game manager and laying down some of the code. So as always, let's start by cleaning this one up. And what we're going to be doing is we're going to be creating some sort of singleton, just like we've done with a couple of other scripts. I don't have one open right now, but it's the private instance and also the public static instance. So I'll do a public static game manager, called it instance, with a getter that returns instance, but not with a capital. Instead, it's going to be with a small letter that is going to be defined right here, like so. Now, here's a quick reminder that we put a get here, but not a set, simply because we'd like people to be able to access this instance, but not to set it. Setting it is going to be something that will be done internally right here through a awake call, actually. So private void awake instance is going to be equal to this. Now, another reference we'll need here is a game state, just like we've defined in the last episode. And we'll call this one state. Doesn't have to be more complex than that. What else do we need here? We don't actually need much. We're going to need a private void update to constantly change the state. Or actually not change, but update it. So update state. And a public void change state, which will, of course, take in a game state S in this case. In which we're going to do the exact same thing we've done in the player motor. So if you guys remember, destroy, set the new state, and then construct. Exact same thing here. And that's it. That's actually all we needed in our game manager. We'll come back very shortly once we have our first state, because we need to define a default one. But at the moment, that's not the case. We don't have one for that. So let's close this one off. We're going to head over to our game state folder and declare the very first state. So let's call it game state initialize, or init. I'll have this one open right now, and here it is. Let's make sure we inherit from game state, and that is where we can do our overrides. But of course, only if those overrides are needed. Now, there ain't much that we have to do here at the moment, because the behavior we have in the game have it so we start running right away with our player. We'd like to actually change this behavior completely. We don't want this to happen anymore. We need to make sure that the player doesn't start running right away, that our player is not active, he's in an idle state instead. So some of the logic we'll have to do is actually going to be over on the player motor. So we have some refactoring to do, basically. So in the meantime, something we can do is the following. We can override the update. And it's not going to be like that forever, but for the moment, let's override the update and say if input, let's use our input manager. So if input manager instance swipe, or let's just say tap. If we tap, let's go ahead and call our brain and do a change state and go to something else that we don't have just yet. So that state is going to be something like get component type of game state game, maybe. So actually running the game and playing the runner game. That is obviously something we don't have at the moment. So let's go ahead and comment this out, but do know that we're going to come back very shortly to this because we'll need to find a way to enter the game. That being said, let's anchor this one. And our next step is going to make sure that our player does not start running anymore. How should we tackle this problem? Well, I believe we should go over to our player controller, player motor actually, and open this one up. And where do we start running exactly? Well, initially, we start running because we are in a running state. In the player motor script, we're going to add a boolean that just says, hey, are we paused or are we not? There will be multiple instances in which our player should not be moving. Assuming we press on the pause button in case there's one, in that case, you don't want to be moving ahead, you don't want to be moving forward. If our player is dead, he should not be moving forward. If we're popped up in a certain menu for some reason, we don't want to be moving forward. And also, if the game hasn't started, we don't want to be moving forward. So we can create a new boolean under the player motor that I just called is paused. And by default, I'd like to set this one to true. Maybe we should do that in the start, actually. So in my start, is pause is going to be equal to true. Now, I'll actually go under the update and block everything. So if we are not paused, so if not paused, then we're going to update the motor. Otherwise, let's not update, which is going to make sure that in case we are paused, then we are not going to update. Now, with this new logic in there, when I press play, technically, we should not be able to move anymore. And that's the case. We're not moving, however, we're getting no reference exception. And I believe that is because, let's double click on it, we have no state and we're trying to update the state. So that's a normal thing. Let's head over to the game manager, make sure we put our new game state initialize on here. I'll open this one up again, the game manager, and I'll assign this one to a default state. So here, state is going to be equal to get component type of game state init. And it's also, as a good practice, construct this state. Now we should have a reference and we will not get this error anymore. And also, good news, our player should not be able to move. And the cool thing is, since we're not moving, our speed is on 0, which means our player is going to play this default animation, which just makes it look good. And he just looks cool now. Now the next step has to do with the game state initialize moving over to game state game. If you guys remember here, we created a couple of line of code here that we're not using just yet because we don't have a game state game. But in the next video, we're going to be creating one, and we're going to make sure this transition happens because our game state initialized right now, it really doesn't do anything, which is, when the game is initialized, we're going to have a couple of buttons to play around with, but there ain't much that needs to happen here, so that's totally fine. So in the next one, we'll go ahead and we'll code the game state game, and we can start the transition in between the two. So I'll see you guys there. In this video, we're going to be creating a simple game state that will launch the player into the game. So to do this, it's going to be fairly simple. We're going to right click on the folder and create a new state once more. This one is going to be called game state game, which is obviously the weirdest name for a script we're going to have in the whole course. So just please bear with me as we create it. It's going to be fairly simple. So game state, game state game is going to inherit from game state. And what we have to do here, in the previous episode, we had our game state initialize that swapped over from initialize to game state game. Now that this one exists, what I'll do is I'll just comment this one out so it can actually run. That being said, what do we do in game state game? Well, we have a player that is currently paused, and we need to make sure this one is enabled so he can start running as soon as this one is created, which means not created, sorry, but swapped over to. So we'll have to override the construct in this case. This, however, puts us in a weird place because we don't really know how to access the player through here, and we don't want to use the find object type of player motor because that's just, that's not so cool. So I'd like to get a reference to my player that lives a little bit longer than just this scope, actually. So what I have a feeling we'll be doing is keeping a reference to the player since we only have one inside of the game manager that we'll be able to call from anywhere, really. So under here, under the game manager, I'll go ahead and I'll create myself a couple of public field, and by couple, I mean only one, actually, player motor, and get the reference to the player motor. I'll actually set that manually through the inspector. We could actually set it in the awake through a find object of type. We could grab a reference in any other reason, like you could grab a find object with tag player. There's a bunch of ways you can do that, get a reference. But you know what? I'll go with the good old drag and drop. So on my game manager, taking the penguin, putting it right here. Since I'm here, I'm also going to drag the game state game, so we don't have that null reference a little bit later on. That being said, now that I have access to this, I should be able to say game manager instance motor, which gives us access to, you guessed it, the player motor. And here, I have a private boolean that is pause, and it is private. Couple of ways we could actually go and fix this. You could say that this is now public and access it directly from the script. However, I'd like to keep this one hidden just for good practice. I'd like to leave that one in the scope and instead create a couple of properties, not properties, but function down here that will have to do with pausing and unpausing the player. So pause player, and also another one for resume player. And I can just say is pause is going to be equal to false. And when I pause the player, is pause is going to be equal to true. See, I'm not going to be using pause player thus far. Maybe later on. Actually, yes, I will be using it later on. But I'm still declaring them just in case that in the future I need to go through a certain loop. I never want to be assigning this value. I like to go through a function instead, because chances are we'll do more than just one thing when we come here. For example, when we pause a player, maybe we want to disable a couple of colliders to keep the game running faster. Maybe we want to hide and show some UI. There is a chance we want to do more than just setting a Boolean here. So that's why I left them inside of a function instead of just swapping over a Boolean, which leads me to do the following in game state game. Resume player, like so. Once a game is constructed, actually once a game state game is constructed, I will now have access to a player that is not paused. So let's give this a try, right? The flow will go like this. First, the game is launch, and then the game manager will initialize itself with the game state in it. Every single frame, we will be looking to update the state. Now remember, in game state init, we're looking for a tap. If a tap happens, we'll be changing the state to game state game. Once this one is constructed, the player will be unfrozen or resume. So let's try this out. See if our logic makes sense. So the game is generated. I'm going to press on my mouse click, and then he starts running. So we have the behavior we want actually already. And that is where we're going to be ending this video. There's a couple of more states to do, but here is a very basic flow in between the two. And when we're going to be done with the game flow section, we'll have an actual game. Right now, it's only going from one state to another and it's being stuck there. But the goal here is to make sure we have a flow in between the applications. So once we die, we can go back to the initialized state, then go back to the game. In a single session, we'll be able to do a full circle, and that's really what we're looking for before the end of this section. So I'll see you in the next one. Cheers. Welcome back. In the last episode, we created the game state game, which was a very simple script. Now today we're going to be creating one that is going to be a little bit harder because we're going to go in two different sections. We have to create the state in which the player dies, and for this we will play with three different scripts: one for the game state, one for the player state, which we haven't created during the player section, and we have to go back also in the player motor to detect some collision. So three big scripts to play around with. And I think we're going to start with the player def state. So under the player motor, I will create a new C# script and call it the def state. So that's going to be everything movement related. And what I'll be doing is I'll just create the base script thus far, and we won't do anything in there just yet. But let's just make sure we lay that down and it inherits from base state. That being said, it's now part of our namespace. I can call it and I can spawn it. What I want to do is head over to the player motor and start detecting collision. Now, we're lucky because there is something called, I believe it is the onController collider hit. It's a function we have access to because we're using a character controller. It's the following. So public void on character, actually onController collider hit. And it's a function that's only available if you are using a character controller. That's something that Unity gives you. As soon as something hits that character controller, then we receive a data structure that is a controller collider hit. If you have a peek at it, it has whoever it hit, I believe, where it hit it, and a couple more information that's going to be very useful. So with this information, we'll be able to know if the thing we've hit is on the def layer. So I'll declare a string right here, call it hit layer name, and I'll call the layer mask static. I could call it, is it class, static class? Static struct, okay, so static structure, and call layer to name here. And it basically takes in a int. It's actually returning you whatever name is associated with certain index. So it's like a lookup to a certain index. Now that index is stored within the hit, so it.layer or gameObject.layer, and that's going to be the layer int of the object we are colliding with. So for example, if we're colliding with the def box, we're going to have a certain int. If that int matches what we have in the dictionary, then it's going to return def over here. So our string will say def. And from that point on, we can look up, hey, is that a layer name def? If so, then the player needs to die. And that means the following. It means a change state for get component type of, do we have a def state? Yeah, we just created one. So def state, just like so. And then I was thinking maybe about pausing the player, but I actually want to create a small animation when you die where you bounce back. And then we can tell our dev state to not process going any further in front of you. So I believe that could be cool. That being said, this code right here should put our player in a dev state. And to test it out, what we can do is head over to here. And for example, we can override process motion and just put a debug.log in here. Def. That's quite dark, but let's give it a try. So technically, if our player hits a collider that has a def on it, we should enter the def state. Oh, and we got a no reference because obviously we created a new state, but we didn't apply it to our object, and it happens to me all the time. So I just made sure to drag and drop the dev state on top of him. Let's go here. And here we are stuck in the dev state, as you can see. And we can't like go outside of it. We can't do anything because there is no transition within that state. But as you can see, it works well. Now the player should be stuck at that point. He should be stuck within his dev state. However, the game is not yet in a dev state. And here is what I would not like to do exactly. I would not like to enter the dev state right away. So if we're entering that, the dev state, and I could say game manager instance, and I want to change it to, for example, the dev state, which I believe you can do here a find object of type game state.def, or I can just do, I'll do it a little bit cleaner, right? So game manager instance, then get component. Could I just do it right here? No, okay. Instance.get component type of game state def, which does not exist just yet. I could do that right here. And I'll leave it in comments because I'd like not to spawn a dev state right away. I would assume that in the future, the dev state is going to create some sort of UI. It will pop up something that requires an action from the player. So maybe the UI will come down and it will ask you, hey, do you want to replay or do you want to go back to the menu? Something of the sort. And if it happens at the exact same time as you die, it's going to be like, okay, you're hitting the wall and then you're triggered right now. Do you want to play again? While this could be the behavior you'd like to have for your game, in mine, I'd like to wait just a little bit. I'd like to play some sort of animation. As I've mentioned, the bouncing back animation. And once that is completed, then we can enter the game state def. So I'll comment this one out. Remind me to create this. Actually, I will remind myself to create this. And instead, what I'll start playing around with. So what I'll be doing now is create some kind of I'll create some kind of animation with code. So it's not something that I'll go in the editor and I'll do it. It's something we'll be creating through mathematics. And it's going to be something based off a vector 3 that I'll call knockback force, which I'll constantly apply to my player. So that's going to be like the move vector. And I'd like this to not move the player on the x-axis. However, put him a little bit high in the air. So 4 in y, maybe that's the jump force, and push him backward on the z-axis, so -3 in this case. With this in mind, I do have gravity. Gravity is on the motor itself, which I inherit, so that's going to be fine. What else could I do? I think we're ready to start coding this animation. All we needed is this, really. So here's what I'll be doing. Hmm. We will declare a vector 3, just like we do. And I'm actually going to copy some code I have over for example, from the running state. I'll copy that here. We start with a vector 3, 0. That's actually not fine with me. We actually like to start with the knockback force. And that knockback force, I will apply some maths to it every single frame. So I'll say knockback force is going to be equal to a new vector 3 every time. So we're always going to have 0 here. So I'll leave 0. Then I'll use whatever value we had in the past minus some sort of gravity. So minus equal motor.gravity times time.delta time. That's for the y component. You can split this in different lines if you wish. That's going to be a little bit easier to understand. So that's the x component, doesn't change. Y component, it's whatever force we define here, minus the gravity every single frame. And then for the z, what could we do for the z? We could up that by the velocity, maybe, so something like that. So I'll just use a constant right now. So 2f times time.delta time. And do we need to do anything? I don't think we're going to need to do anything here. We can just return the knockback force. Actually, we're going to need to do something here. We're going to have to make sure that the knockback force here, I gain speed on the z-axis. Initially, my speed is -3, and then I gain speed. I want to make sure that this does not go past 1. So we start in negative, and we want to stay negative until we hit 0. So here's what we'll do. If our knockback force.z goes beyond than 0, I want to make sure that my knockback force is clamped. So I'll say knockback force dot z is going to be equal to 0. And then from that point on, once that happens, then I can put this line of code here. Because only then, only when this is done, this animation is done, we can change state and go to the game state def, which does not exist just yet. So let's leave it in comment, but that's where it's going to be. Okay, this was a lot of code, a lot of maths, a lot of theory. Let's hope that everything works perfectly on the first try. And it's not bad. I did expect the player to go up in the air, but it really didn't. And as you can see, my knockback force here is going crazy. It's going and incrementing quite fast. So maybe I want to make sure that this does not happen. And I have a feeling the problem came from these default value here. I had some default value 4, -3 in place. That's not what I want. I want 0, 4, and -3. So maybe that came from the inspector causing me issues. So let's give this a second look. There you go. That's much better. And that's actually what I wanted to see. And if you want to give it a try, just play around with the numbers, have a look with this formula. I'm going to put 15 here, so our player is going to jump really high in the air as he hits this. Obviously not so realistic, but it does give it a certain style. So play around with this value. If you want to be pushed back a lot further, you can also increment the -3. For example, -6. And he's eventually going to stop and sit there. I think we're not missing much to make this happen. We're missing a animation, and we do have access to one animation, and it's called the def animation. So let's head back in the construct, call the motor .anim, and we'd like to always put that question mark here in case we don't have a reference to the anim, and set that trigger to, I believe, which is def with a capital P, like so. Okay. With that in mind, we are going to launch this once more. And there we go. This looks a lot better, so this makes a lot of sense. Of course, the only issue we have here is the fact that we're dead and really nothing happens from this point on. We can't transition out, and I believe that's a good way to put it. So if you cannot transition outside of def, we should be able to control it from somewhere else, and that is where this line of code comes in. We need to tell the game to do something. So the game state needs to change, and that is where we're finally going to create that game state def. Into the game state folder, finally, that's what we're here for in the first place, and create the game state def. And now our code here works. Well, except the fact that it still does not inherit from game state. So let's go here, put it, and now it works. Okay, as always, we'd like to clean up everything. And now from the game state def, we'd like to control a couple of things, and those things will be the following. Entering another game session, replaying the game from where we are at right now, in case the player decides to watch an ad or something of the sort, and maybe just going back to the menu. So 3 things. Either replay the game from the same point you're on, and go back to the menu. And all these things can be controlled within the game state def. Now, for the moment, the only thing we can really do, because we don't have any UI we can click on, we can use a couple of things. We can override the update state and just put some stuff in regard to our inputs right here. So I can say input manager instance tap. If we decide to tap, then what could we do when we tap? Should we start over from where we at? Or should we go to the menu? Here's what we'll do. If we swipe down, we will go back to the menu, and that's going to be a public function I'll call here. So I'll just call it to menu. So if we swipe down, we're going to call it to menu. And if we swipe up, we're going to replay the game, I believe. Now we just have to find a way to go to these without any issue. So we could do the following. So if we do a resume game, we need to respawn the player where it was initially. And for that, we can have access to the game manager instance motor, respawn player. We have resume player. Let's call respawn player, which is going to be a new function we'll have to lay down within the motor. And will we need anything else? Yeah, we'll need to change the state of the game back to game. So brain change state to get component type of game state game, like so. Now, once we go to the menu, upon going to the menu, what we'll need is to set the game state to initialize. So game state initialize. And let's see, what else will we need? I don't think we'll need anything else, actually. Just changing it will trigger enough action that will put us back on the other state. Okay, so I believe everything here is perfect. We are going to need to respawn the player, however, so put the player back in a certain state, which we can do by going and implementing the respawn player function. So upon respawning the player, this is where I'm going to be wanting the player to change its state to game component type of the respawn state, which unfortunately does not exist just yet. So it's another one of these where we're going to have to code it because we didn't do it in the player motor. And now I was debating whether or not I should be doing it in the same video, and I believe that we should because it's all related to the def state. So let's actually go ahead and head over to our player once more, create a new state for him, and that new state is going to be the final one called the respawn state. And once more, it will, of course, inherit from base state, and it would have a couple of logic in here. The goal of this state is to make sure that we spawn the player very high in the air. And the reason for that is if we spawn him at the bottom because he ran into a wall, he's just going to run into the same wall immediately if we put him back exactly where he was. So it's going to be important for it to not be exactly there. Now, as far as the respawn player state goes, it's something we'll be implementing in the next video, but right now, I just like to see if it works, so I'll just go ahead and say respawn. The reason I'll be doing it in a next video is simply because it's going to be quite a topic as well. Maybe a 3 or 4 minute video on its own, simply because we'll need a new player state. Just like we needed a new player state for dying in this one, we'll need a new player state for respawning. The goal behind it is that we spawn somewhere else than where we died, for the sole purpose that if we spawn at the same place, we're just going to die again. So let's give this a try. If I hit the wall, I'm now in the dev state for the game as well. And as you can see here, we have issues, most likely because I'm missing a couple of things. So first, on the game manager, I'm missing the game state def. That seemed to be the first problem. And second, it feels like I had a null reference here as well. Oh yeah, it's the same thing. So as I was changing the state, I did not find anything for game state def. So I did have a null reference there as well. Now, if I give this one more try, and we run to the wall, upon dying here, I'll have two options. Either I swipe up for respawning, so swipe up is going to say respawn, and then I shouldn't be able to do anything really. Oh, actually, I can spam respawn, so something is not right here. This is being called, but then the change state does not seem to occur because I am not changing state. I'm still calling the private void update state here. So what could be the issue? Let me check. I have a feeling that I know what's happening. So it feels like I'm going back inside of the game state game, and then I get stuck in a loop because the player keeps hitting the same object. It puts me back in the game state def loop all the time. So if I was to take this guess, it means that if I override the construct, I should get spam by the construct, and that is not a good thing. So I'll just say def construct. Oh, and I'm not getting Unity Engine here, so let me just make sure we have it. There we go. So sorry to enter this debug session, but it's something I have to do here. So this is being called every single frame, which means that I'll do a control search on game state def, and I'll find out where we call it. We call it over here. Our player in the def state constantly ask this person to just to go over here and change the state. So something that I feel like doing here is once we enter the game state def, then at that point we can pause the player. So here on the game state def construct, here I will say, let's have a reference to the player. How should we do that? We have one on the game manager, I believe, so motor. And here we can pause the player. Or maybe we can even create another function that does that, but on player def maybe. But pause player will do it quite well. And I think that's going to be fixing our issue we have here. Let's give this a try. If not, I will look stupid, so it better work. Okay, so we're not being spam anymore because I removed the debug.log, but let's give this a try. If I swipe up, I get respawn, and then I'm going to clear this and try to swipe up again. Okay, so I'm still being respawned, which means I'm still in that state. So I came back and I put another def construct in there. See if this actually works here. What I have in mind here is I'm just going to go back and see what happened. Def construct is only called once, but oh, see here, I respawn and then I'm put back in def construct. So what happened is when I respawn, I feel like upon respawning, let's see, we resume the player. So let's see. This happened, that's totally fine. Okay, and then game state game starts over again. And from that point on, our player is resumed. Okay, so that's totally on my bad. It's actually intended behavior, so that's good to know. But do remember that once we resume the game later on, we will spawn far up in the air, and that will not happen. But okay, so this part works well. Now the swipe down and going to menu. If I am to clear my log and do a swipe down, technically I should be in the menu state. And then if I tap, yep, def construct because I respawn again. So both here, they work well. And just to show that they work well, I'm going to go here on the swipe down. When it goes to menu, game state init, I'll go here. Oops, wrong button. And upon creating that state, which of course we'll build on later, I'll do a debug.log. And you know what? Something I could have done even before that, on the base state, on all the construct for every single state that is game state, for the moment, I'll just put a debug.log and say something of the sort. Constructing, can't type English, this.name. And with that in mind, it means that every time I call construct, unless I overwrite it here, just like I do, say over here, it's going to say constructing that state. And just for the purpose of this, I'll call the base constructor here. Okay. All right, back in our loop, final test before we head on to the next video. Sorry, this was a long one. When we're constructing the game manager. Okay, small typo, my bad. Let's fix this quickly. This toString, I believe, is what we needed here because we'd like to get this. This is actually the class and not the game object. When I just do this.name, it gets the name of the game object, which in this case is the game manager, but I'd like to get this being the class while I'm calling it within the class. So constructing game manager game state initialize here. And if I press on tab, technically I should have called game state game, but I believe we're also overriding it. So yeah, over here we override game state game. So we could go and say base.construct and give this our final try for real this time. Game state initialize, we start game state game, we die, game state def, we try to respawn, we enter game state game, but then right away we're put in def, that's totally fine. And here we go down, we're in the menu, so everything should be stalled. And then we tap, enter game into def, because of course, well, we're on the floor. So our behavior works just fine. It just doesn't look good thus far. And that's something we'll fix very, very shortly. But we have a full loop, a full circle happening. Logic just isn't in there yet. But bear with me because in the next one, we will implement the respawn logic and also the respawn state. So after that, it's going to look a lot better. And then we can start maybe inputting some of the cameras, which is going to give it a whole new feel. But guys, I'll see you in the next one. Cheers. Hey guys, last time we left off, we were in the middle of creating a state for when the player is being respawned. At the moment, we had a behavior in which every time we would go and die, we would try and restart the game to the point where it was, but then we never reset the player position and we never put him in the air, and he would just end up dying again. So today we're going to be creating that state, a special state that would only happen when you decide to respawn the player. So let's head over to the state folder, create a new C#, and it's going to be a respawn state. This one is going to have a couple of mathematics in there, and I believe it's also going to have some kind of hotfix because we're going to do a workaround some bug that is in the Unity engine as this version goes. So we're currently in 19.1, I believe, and it hasn't been fixed in 2020 as far as I can recall. So that being said, we are going to inherit from base state, as we always do. And we're going to start overriding a couple of things. Most of what we're going to be doing in this one happens immediately once we enter the state. So we'd like to teleport our player up, so very high in the air, so it can avoid all the obstacle. And to do so, we're going to override construct. So here's what we'll do. We'll take the transform dot position of the player, and we will put it somewhere at the top here. So I'll do a new vector 3. 0 and x, we'll spawn him directly. So we're going to spawn him directly in the middle lane. In terms of the height at which we should spawn him, that's going to be something that varies. So I'll create myself a field here. Oh, sorry, not something that varies, but something that gets configured. So private float vertical distance. And let's try to spawn him at 25 meter in the air. Now, as far as the z-axis, if we are respawning, we should be exactly where we were on the z-axis. So motor, transform, position, z. Okay. Should we give this a try? I think we should actually stop right here and give this a try. Let's hook in our respawn state. And I believe we did that in the game state def. Is that it? So whenever we were to respawn the player, under the player motor, we did a debug.log.respawn. Right here, we're going to be doing the following. Change state to the respawn state. Just like so. And let's make sure we add it on our player as well, so we can see the behavior of this. And the reason I'd like to show you that behavior is because you'll see what the bug is. There's a small bug I was talking about. So as we run into this wall, we're going to die, and then we're going to swipe up, choose to respawn. And you'll see that, well, I mean, the construct has been called, obviously, because we are in the respawn state, as it says right here, but we have not been teleported. And that's an issue. That's an issue because we said, hey, our transformed position, it should be right here. And that's clearly not where we are. So this behavior actually comes from us moving the position directly without going through the motor.controller. Usually what you would do is something of the sort. So motor.controller.move, and then you would move a certain motion. But do note that this is a more complex function than just moving absolutely. Like it says right here, it's not actually moving the exact same way as just moving the position. When you just move the position, you ignore everything. So you ignore colliders, you ignore everything that has to do with physics. You just place an object in the world. When we do a dot move, it actually accounts for those. And if you have a ceiling above you, then you're not going to be able to be put up in the sky because you're going to be blocked there. So we are going to not use dot move. Instead, we'd like to teleport directly like we've been doing. But before that, here is the workaround that I found. We're actually going to disable the controller, move him, and then re-enable the controller. Just like so. Let's give this a try, see if it works. So we die, and then up in the air, and as you can see, we are now being teleported way higher in the air. And obviously we have a little bit of problem when it comes down to spawning this here at the top in terms of what we see, but it's something we'll address once we start playing around with camera. I'd like to have a different camera angle when I start falling, not just the same one. But right now, as you can see, we have been teleported in the air. Our workaround was a success, but of course, there's still a couple of things to play around with here. And that first thing is the process motion. As it says right here, process motion is not being implemented in respawn state, and obviously we have to do so. So let's go ahead and override that so we have some sort of movement at least. And let me just grab whatever I have in the running state. I don't know why I like to use this one, but copy. Now, what should we do in the process motion? Now, in terms of processing that certain motion here, it's going to be very, very similar to the jumping state, actually, but I'll allow the person to change lane, which I think we do here. Okay, no, we don't. But here is what we'll do. I'm actually going to grab everything that I have in the jumping state instead. My bad for making you copy twice if you're following carefully. We're going to start by applying the gravity, create our vector, snap to a lane that we've chosen, apply the vertical velocity, and also we have the base run speed. Yeah, I believe that's all we would need here. Obviously, we'll also need to do a little bit of transition. So I do encourage you to go ahead and maybe grab this one. So falling state is a little bit better here because we want to keep this is grounded call. When we're going to go back to the floor, we would like to be put back on the running state. So I grabbed the exact same transition as I had in the running state. And what I'd like to do is actually, when you're falling, it'd be good to guess and choose where you're going to be landing in between each of the lane. so you don't fall on something else that's going to kill you. So you have an actual control while you're respawning. So I'll head back in the running state, I believe. Yep. And grab the swipe left and also swipe right. And I think we've got everything we need here. Maybe I'd like to, oh no, yeah, I would like to also reset my vertical velocity here. So motor.vertical velocity is going to be equal to 0. We're going to start and we're not going to fall very, very fast initially. Also, do note that we're never going to fall really, really fast because apply gravity clamps the gravity to our terminal velocity. So we're never going to go faster than 20 meter a second on the y-axis, which is quite fast already. So, but do note that we're never going to go beyond that point, which is good. Okay, that being said, let's give it a try. And I'm going to swipe up. And there we go. Let's keep trying this. So can I swipe? I actually can't change lane right now, which is bothersome to me. I don't know why, but I don't seem to be able to change the lane. So let's try and figure out why that is. Maybe something I've done here that I forgot is to actually change the current lane as well. So current lane should be put on 0 simply because we're spawning on the 0 axis here. So I just manually changed that as well. I don't think that's going to save everything, but let's give it a try. Okay, so I was able to change lane, but only once I've hit the floor. So clearly something's happening as I'm falling. That doesn't allow me to change the lane. And it also seems like I'm not being pushed back anymore when I die for the second time. Like I should have that nice little bouncing animation back. Okay, so before I fix that immediate problem, I'm also going to trigger a certain animation here so it looks a little bit better and I can maybe this gives me a better idea of what's going on. We're going to set the trigger to respawn. I believe we did have a parameter trigger that would allow this to happen. And let's give this one more try. So as we are respawning, we're falling into a certain state, animation needs to be corrected, and then once we hit the death state again for our player, clearly it's happening because we're getting the animation. The only problem is that it really doesn't do the bounce back, so some values need to be reset somehow. And here's the problem that I found with this very specific problem here. Our knockback force is a scoped value, and we never delete dev state. We only have it once because it's a little bit more optimal to have it once. So we don't instantiate this on the fly. Therefore, when we modify the knockback force, it actually stays a certain way. So let's make sure that every time we construct this, we reset it to the default value, the base value. So what I'd like to do here, we would need to save this in a different value. Let's do private vector3 current knockback. And that current knockback, every time we construct, would be set to the knockback force. And this is the one we would be modifying every single time. So let me just modify all of that to current knockback. And that should do it. So that should fix it. Okay, one of the problems should be addressed with this. So as we die, spawn up, die again. Okay, we get this now, and we can respawn. Animation will need a little bit of fixing, but before we do that, let's try and have our player change lane. Right now, I'm currently trying to swipe left, 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 and I'm not getting any changement of lane, which is a issue for me. So let's try and figure out what goes on. One of the problems that I possibly see it is maybe that we transition over to this running state a little bit too fast. I actually haven't seen it, but if we were to track the flow, this is what I think is happening. We enter the respawn, we're in the death state, we enter the respawn state. On the very next frame, we are being put in the running state because it thinks it's grounded, probably because we move this like in a cheat way, like we move this using the transform.position. And then what probably happens is, as it is in the walking state, it realizes we're falling, and then it goes into a running state, or sorry, falling state. So a bunch of things actually happening here, I believe. And we could test this out just by doing exactly what we've done with the previous states. We could just go in the awake and do a debug.log here, but we would have to go back. So I'm just going to assume that what I've said is true. And with that in mind, it means that I could go, for example, in the debug state and say, am I falling? And if this message pops up while we are in the middle of the respawn state, it would mean that it's actually happening. So I just clear my console as I'm going to reset this. It says, am I falling? Which means we have constructed the falling state. And our problem comes 100% from this call here. So we are swapping over to the running state on the very first frame. So we're going to have to find a way to work around this. And what we could do with this is create some sort of immunity. So we might be immune for a certain time to that very specific thing. And it's a very simple concept to do. And here's how we can implement this. We can create a new private float, call it immunity time, maybe 0.5 second, or it could be a lot more than that, actually. It could be like a whole second. And in the construct, oh, and my bad, this one would be, you can modify this one, why not? And then I'd have another float for start time. In the construct, I would say start time is equal to time.time, which gives us a timestamp on exactly when this respawn state has been created. And then in my transition, I would look for two things. First, are we grounded? And time.time minus when we started. So that's the time difference in between when we started and now. Is that bigger than the immunity time? If so, then carry on, and you're now allowed to go in the running state. And that should address our very last bug that we've had with this state. So as you can see, I can move left and right now as I am in the respawn state. The only thing we're missing to make this look a little bit better is a different camera angle, so we know exactly where we land. And that is pretty much it. So we should be done with the respawn state, which looks a lot better than used to in the previous episode. And the next step is going to be to start hooking up our different cameras. It's going to be something that makes a very big difference. So please stick along with the next video. It's going to give you a much better feel for the game. So I'll see you guys there. Welcome to what should be the last episode of the game flow section, in which we are going to code a little bit of things in the game manager. And we are also going to import a package in regard to cameras. So our goal today is going to be to create different type of cameras and also allow the switch in between these cameras to happen. And we'll code that directly in the game states over here. So that being said, let's go ahead and open the window, package manager window, and we will find the Cinemachine. Of course, make sure that you accept all the packages and that you're connected to the internet. Here, Cinemachine is what we'll be using. It's actually a tool that will pretty much override all our cameras and will give us nice little effect and also give us a good way to work with camera. It is a tool that is very, very fun to use. So I do invite you to install it with the bottom right button here. Once you have that package, I do invite you to create a new game object that you will just call camera, or maybe camera with an S, because there's going to be multiple camera in here. And just have that empty game object sit there. Maybe you want to put a new color to it. And this object is going to contain all the other cameras within it. And I believe we're going to have around 4 different cameras for a game. One for when we boot the game, so the initialize camera. One for the shop, one for the game, and one while we are respawning. Now you will also notice that at the very top in your Unity menu here, you will now have the Cinemachine menu, and it has a couple of things here. And I do invite you to look at the optional videos in this section to know more about these cameras. But what we'll be mostly using here are virtual camera. And I believe that is pretty much it for this one. So I'm going to create my first virtual camera. And here's what we'll do. We'll first rename this camera for camera, maybe underscore initialize, and then we'll make it a children of camera just so I can know where all my cameras are. So this one is sitting right here on top of the other object. I will then move this camera, and you will realize that moving this virtual camera actually moved my real camera. And that's the behavior we'd like to have, but at the same time, it might confuse you a little bit. So it'd be cool if you just go back on Penguin, take the main camera, and just pull it out on its own now. We are no longer the children of the Penguin. This camera now behave on its own. And if you try to move the main camera, you'll see that it doesn't do anything. It doesn't want to move because main camera is no longer being controlled by its own transform. It's actually being controlled by whoever has the priority. So as I try to move the object that doesn't really have the main camera on it, but only has the virtual camera, this is actually moving the real camera now as well. So it's important to know that the main camera is now connected to the virtual camera systems. And that is because the main camera has a Cinemachine brain attached to it. And if you were to disable that, then you go back to having a typical normal camera that you can move around. But really, what makes this work with the virtual camera is the Cinemachine brain. And as soon as you've created a camera in here, a virtual camera, it actually added this component automatically. And sometimes it's a little bit annoying because it doesn't tell you, but I'm telling you now that on your main camera, this has now popped up. You have a couple of things here you can play around with. Show debug text might be very important to you because it's going to tell you which camera really has the control over the main camera right now. So at the top left, you'll see that the main camera is being controlled by camera underscore initialize. The rest of the parameter I'll ignore for the moment and we'll explore more of them in the optional video section. For the moment, it's really important that we know that our camera initialize actually drives the main camera. And to prove my point a little bit further, here's what we'll do. We will start laying down the game camera as well. So I just duplicated this object and I'm going to call this one camera game. And let's take the game camera and actually look at the player or something like that. So we see a difference in between the initialize. Initialize is just going to be, oh, let's do it the other way around actually. So for initialize, I'll be looking at the player, something like that. And for game, I'll be looking in front of the player, like so. So that would be the game camera. And as you can see, the CM main camera actually is being controlled by camera game. And if I am to disable this one, it's going to jump to the most, the closest one you could say. And as I toggle them on and off, you'll see the camera actually switches automatically in between them. Now, what determines which one has priority is actually a component called priority right here. So for example, if you'd like to have the initialize camera have priority over initialize, then you can just up that number a little bit and you'll see the difference. In terms of our implementation of Cinemachine, we're actually not going to be using priority. Instead, what we'll do is, as I've just shown, we are going to disable and re-enable camera depending on which one we need. For example, if we're in the game, we're going to disable all the camera, and then this will go directly to this one. Okay. All right, so we will be laying down the two other camera very shortly, but before we do that, I would like to get into making these work first. So what I'll be doing next is we will start coding a very small function within the game manager in order to change these cameras. So we'll need two things in order to do that. First, a function that allows you to change in between the camera, and also the list of all the game objects we'd like to turn off. We could do it in a couple of ways. We could have a public list, a public array. We could have just a reference to parent. For this one, I'll actually use, say, a public array. So we can do public game object, type of game object, and it's just going to be all the cameras. So with this in mind, I can now save, head back into my game, find the game manager, and declare a list of 4. one for initialize, then into game, then shop. So I'll just duplicate these right now. One for shop and one for respawn. Let's add them. And right now, these are all the same. So game, shop, and respawn, they're all the same. Please don't worry about that. We'll be configuring them very, very shortly. And do note the order here. So initialize is 0, game is 1, 2 for shop, and then 3 for respawn. Because I'll create myself a small helper enum at the top here. Public enum camera. We can start with initialize is 0. Game was 2. Oh, sorry, 1. Shop was 2. And respawn was 3. And having it called just camera is not going to work. So we could call it camera or game camera. That could do it. Just camera itself would be a conflict with Unity's definition of camera. So we have to name it something else. The reason I want to actually have this is for the following. When I create my public void change camera, instead of sending it a int, let me have a game camera being sent instead. So this is going to be a tad easier to call from outside. Now all we have to do here is run a for each of all the cameras. So all the game object geo in cameras, like so, and disable all of them. So set active false, and then finally re-enable the one that we're using. So camera at the index int c dot set active true. So what's happening here, if I send, for example, camera shop is equal to 2. So when I cast this to an int, it gives me 2. And then I do set active to true. Should be fair enough. Okay. Now, what we need to do is start implementing this around our game states. So when we enter initialize, game state initialize, we'd like to have the initial camera. So we can do a public override construct and call game manager instance change camera type of initialize. That's really all we need to do. And I'm going to copy this over because we'll use this code again in the following state, which should be game state game. Here we go. So same thing as before, but here we are going to be changing the camera to the game camera. And I'm not going to go any further right now. I'd just like to test this out, see if it works properly. So when I press on play, I have the initialized camera. And then when I swap, it goes to the other camera, which it did work. It was very long, but it did work. And also, I don't know if you guys realize, but it was not actually following my player around. Here, my player is going. It's doing its thing right now, but the camera is not following him. So definitely that's a problem. Now, in order to configure this, we have to jump into the game camera, so this one, and tell it to follow something. That something right here will be the player, of course. So I'll add the penguin in here. And then this is where we get to play around with the angle we would like to have. So we now have a follow target. It's time to start playing around with the settings. The body of that follow and also the aim. The body is where the camera is going to be positioned in the space. The aim is going to be its rotation. So for example, here, we would like to have a certain offset. So I'm just moving on the y-axis. It's going to be important you play around with this and you find the one that you like the most, the settings you like the most. Here are the one that I've been playing around with for a bit now. And if you're tired of seeing the guide, so this thing, you can disable it at the top right side here. So what I have is the following. I am on transposer. I'm locking my target with the world up. 5 minus 5 are my offset for the position. And then for the composer, I went with 6. So the track offset in Z is 6, and I left the default settings down there, the one that already existed. So that's what I have for the game camera, and I'm quite satisfied, and also made sure to save during play. And that's the behavior I have for the game camera, which is, I believe that's exactly what I wanted. Now, one of the problem we have right here is how long it takes in between the switch for the initialized camera to the game camera. One thing that is really cool with this system is that you can actually customize that very switch in between these two specifically. So if I am to go under my brain, so my camera brain, here it is, under the Snip Machine brain, there is a custom blend. So you can do a blend for everything. In case I want to do a cut, I can just put cut and you'll see that that's the default blend. It's just gonna go straight to the camera. And that will be applied to every single camera right now. But maybe that's not what we want. Instead, let's do a easy in out of say 0.5 second for all of them. But in case we want to change things specifically in between, say, the initialized camera and also the game camera, we can create a custom blend, which is which is actually exactly what it sounds like. So it's a custom blend in between two different camera, and I'm going to put that under scripts and also the game flow, game state maybe, or maybe no, the main camera blend. Here it is, under game flow. And if we open this one up, you get to actually choose what you want to do here. So for example, we can do from initialize, so the initialized camera to the game camera. If you pull that up, you'll see you can decide to do, say, easy in out of 0.75 second, which is a little bit longer than the default one. And it's going to take a little bit longer to load this one. So that's exactly how we can do that. Now, in terms of the rest of the camera, I know I've been renting for quite a while now, but we can easily hook in those other camera very, very fast. So if I was to go back on initialize, the camera shop, not so much, but at least the respawn, that is something we can do for sure right now. So here is what I'll do. I'll actually copy the Snip Machine virtual camera. I'll copy that over, the one for game, and I'll go apply it. So paste component value to the respawn camera. So at least it keeps these settings. Let me just reset everything we had. So it goes back to this. It's now time for me to actually swap over to the camera respawn. And to do so, I believe we would do it in the, should we do it in a game state def? No, this should be triggered in when the player actually enters the respawn state. So when we enter the respawn state for the player, this is the movement. In the motor, in the construct state, we are going to be calling our new camera. So game manager, instance, change camera with camera type of respawn. So that will be done in the construct of the respawn state. And right away, you'll see that we'll swap in between the game and the respawn camera. So that's good. But this one is not configured at the moment. So it would be important we do so right now. And the behavior I would like to have for this one is simply to have it the exact same thing as the game, but to look at it from directly over the player almost. So if I am just to move the Z component to say maybe directly on top of him, so 0 and Z, and just look down in a certain angle, like so, this is the behavior I'd be looking for. Now, obviously, we're going to be far high in the air like this. Maybe you want to move your player around to configure this a little bit better. And this could actually do it. So something that's going to look directly down, something like so. Okay, putting my player back to where it was. It's now time to give this a try. So let's hit respawn. And I have a feeling that it didn't work so well, so let's give it a try. As you can see, we are under the game camera, so something definitely did not work here. We were expecting to enter the other camera for some reason. Let's see what could have gone wrong. Okay, so I was able to find the issue here, and it has to do with timing at which I am calling this. This actually should not be called within the respawn state, because when we call the respawn state, we launch our game state once more, and sometimes we launch a game state because we are starting the game initially, and sometimes we start it because we respawn at the same point, and we only want to trigger on camera in the second case. So I'll be moving this one in a different part of the code. Yes, it was being called, but the problem is that it was overwritten by this call right here on the game state game, which was the change camera. Instead, we should only call this when the player is being revived, and we can do so under here, under the respawn player. That is a call that is only called the moment that we have to respawn the player. This starts the respawn state, and let me check something real quick. So going back to where this behavior starts, the respawning behavior actually starts from when you are dead. You need to be dead in order to revive. So what happened is when you decide to revive, right here with a swipe up, you are then put under resume game, which respawns the player and then put the game state back on game. And this is where I think we should swap them around and have the state being changed first, and then we head into respawn player, at which point we can say, okay, then go ahead and change the camera. We could do it here, but I'd prefer doing it under the respawn player. It makes a little bit more sense. So if I go under respawn player, I'm going to do a game manager. So game manager instance, change camera, type of respawn. And I believe now, if there is no logic that breaks this, so if there is no required logic in respawn player that change the game state game, we should be fine. So let's give this a try. And I'm going to die here. We are under the game camera. As you can see here, it's only one that is active. So we're under here. Then we're being put under camera respawn. It's also the case we see it at the top here. So this works. Now we just have nothing going back to. So once we leave the respawn state, we want to go back to being in the game state. So that's going to be very important. We do that, and let's actually do it right now. So under our respawn state, let's create a destruct call. So public override destruct, and under here, I will say the following: game manager instance change camera type of game. Going back in game, I should have everything I need at this point. Yep, exactly. So our whole flow now works. The only problem is when we respawn, like immediately right here, we get a really weird behavior and we have a look at the sky. So what we can do here, from what we've learned earlier, is we could override that transition to be a cut. So if I go under my main camera, under my custom blend, I decide that my transition in between game to respawn is actually going to be a cut. Save this. And do remember here that when we do die, so when we die over here, a UI should pop up, should cover the screen, and then we're going to click on the button, and then this will happen. So we're instantly being teleported to the sky, and our camera is being swapped in the respawn camera. So this behavior is a lot easier to deal with, as you could see. And there it is. So we were able to hook in the cameras in a single video. Sorry about how long this one was, but it's a very simple system once you get the hang of it, and it's very fun to play around with. We're not completely done because we'll come back to camera at one point because we need to have a shop camera. Maybe we want to tweak some camera. We want to tweak them a tad bit, but I'm not quite sure as of right now what else we should be doing until we have the shop. So let's leave it at that for now, and we now have a game that plays itself. We have a game flow. So, all right, guys. In the following section, I believe we're going to start tackling a little bit of the UI so we can start to see what goes on in the screen. We can start getting a cue of what to do. And also we have buttons to click in at the beginning. So we just don't look like, there's secret commands that happens right here. All right, guys, so this does not actually conclude this section. We still have one thing to look at in the next video, and it's going to be the fact that we have a little bit of polishing to do here. If we decide to go back to the menu, so if we decide to not play again and go back to the menu, we end up with this weird bug where the player is all the way over there, and we don't have any floor over here, and it just looks very, very weird. So something we'll be fixing in the next video, and it's very important that you tag along for this one as well because it's part of the logic. is the whole resetting behavior of one, the world, second, the player, and I believe that's it. Yeah, the world and the player. So tune along with the next one, and after that, we'll have a full, complete game flow we can play around with. I'll see you guys in the next one. Cheers. Welcome to the final episode of the game flow section, in which we're going to fix this issue right here. So when we decide to go back to the menu, we have two options. First, we have the option to respawn when we die, and we also have the option to go back to the menu, which takes our player and should technically send him over here and back into the original flow. But that is not the case right now. So let's go ahead and hook ourselves in the code somewhere where we can reset the player position. And I believe we should do that when we're exiting the game state def. So once we leave the def, we are going to reset pretty much a couple of things. So let's take the player position, for example, through the game manager instance motor. That's the game player. And we can set its transform the position back to vector 3.0. And since we're not moving in that frame, because the thing is going to be paused, then we get to have a behavior here where we don't have to disable the controller first. So by doing this, we should actually take the player and move him exactly to back to the start. Once we enter the option to menu, and that happens, if you guys remember, when we swipe down. So our player, where is the player? He is right here. However, the problem with this is the fact that, of course, his animation state is literally on the floor. So we would have to reset his whole state machine because I remember we didn't actually hook anything back to the idle state. So here's something we can do to fix this issue. We could go ahead and create a new parameter. And if you're downloading the file from the web, this should already be done. A trigger called idle, then hook it from any state to idle with no exit time, and I'll make it instant. So I'll just crush that down like so. The condition will be idle. Saving this, I can now head back into my code and call this trigger. Set trigger idle. And by doing so, we'll be able to reset the state machine to where it should actually be. So if I am to play this now, and we have a look, we're currently in the run state, into the def state, and now I'm going to swipe down back into the idle state, which gives us this behavior, and that's something we'd like. But as you can see here, I was able to respawn, so obviously something was wrong here. So currently, if I tap, I'm not actually moving, and I believe that is because our player is, for some reason we can swipe out, so our player is definitely in the wrong state. So to get through this problem, we would have to actually switch the state of the player. So I would call a change state on this player. So again, game manager, instance, motor, get component, if that's a very long call. We're going to be in a running state because that's the default state we're in when we start. And then maybe we want to pause him right away. So we have reset his state. Now let's pause the player. Quite a couple of things to do, and it's all inside of to menu. Now you're going to see here that we have 4 different calls to game manager instance at motor, so that might be a little bit too heavy. So something we might want to do is head over to that motor and create a function instead with all of this inside. So that's exactly what I'll do here. So instance motor, and we will call it reset player. With that in mind, I will grab all of this, head into the player motor, and create a function for resetting the player. So public void reset player. Paste all of that. We won't need any of these reference anymore. And yep, it feels, oh, here, we don't need that anymore either. Yeah, it looks a little bit better. So let's see what happens if we run this code now. So I'm going to swipe down. It goes back here, press play, and it starts over again. So that seems to work just fine. I feel like I have a little bit of glitch here in terms of cameras, so I don't know. Let me just pull that up so I can see the behavior. It seems to be hard for the camera to actually go back to initialize because for a single frame, it thinks that the player is here and then right after he's right there. So what I believe we'll do is a custom blend. So when we reset, we'll do a custom blend in between the actually the game camera and also the initialized one. So going back on my main camera down here, the game camera over to the initialize is also going to be a cut, which should remove the small weird glitchy behavior I had when I decided to reset. And yep, we go straight back here. Don't seem to have any issue anymore. And I believe that's exactly what we need. Now, there's one problem that we haven't fixed and that we haven't even seen this far. And to see it, I'll need to play the game a tiny bit. Okay, and here we go. And the problem will manifest right here if I try to respawn. There's nothing in front of me. And that's because the world is actually much further beyond that point. And as you can tell, the things don't actually spawn until we get to that point. That's because that's where our world manager thinks we are. And when we reset the world, when we reset the player, we don't actually reset the world. So we'll have to find a way to call the world manager and tell him to reset himself as well. So exactly where we do a reset player, I believe that was on the game state def, we're going to do the same thing here with the world manager. And do we have an instance to this? I don't believe we do. So let's find out what we can do with the world manager. Oh, here it is. We already had a function called reset world, and we had to delete this as well. Okay. With that in mind, I will create a reference. So from the game manager, I'll create a reference to world generation. Now, let me just comment this out real quick. Go on my game manager. I do have a public player motor. I'll also have a public game, actually world generation, and call it world generation. Now with this, I can go back on my def state, game state def, and call the world by doing instance world generation. And there was a function already in there called reset world. And I'm eager to just see what this one does without going into detail right now. I'm just eager to see if we coded something that could work on the fly before. That'd be nice. And before I run this, I'm going to make sure to assign my reference under the game manager. So here it is. Let's go ahead and press play. I don't need to play the game for too long to see if it's going to work or not. I just need the first prefab to despawn. So just in any second now, there it is. Now if I die, swipe down. Okay, the world has not been regenerated, so let's go see what this does. This puts us back on where it should, and it deletes a bunch of chunk, and it should spawn a bunch of chunks. So for some reason, this was not, I believe this was not called. Okay, so I seem to understand what the problem is with this one. The code we have in world generation works well. The only problem is that our camera is so far in the future, and as soon as we call this code, we get to have the code that creates new chunks. So what happened is those chunks are being created, but then they despawn automatically because scan position goes through, and then we delete chunks. It's as simple as that. So something that would be good to do is that inside the scan position, it would only be good to do that while we are currently in the game state. So we don't need to scan the position at all in any other state than when we are in the game state. The scan position is only here to spawn and also despawn chunks based on where the camera is. Now, what happens is during one single frame, it just runs this like couple of times and it deletes the couple of chunks that we see here. So it'd be nice to wrap this up in a if statement. So this whole function here, and we could do so in the update. Now, let me think about where we could put that in. Technically, what we could do is we could be in the game state game and call the update from there because we do have access to that. So public override update state, and from here we could say game instance, actually, oops, game manager instance world generation, and then we can't call the update like that, so we'll have to rename it. So scan position. Let me go back on the world generation. I'll make this one a public void, and I'll delete the update statement in here. So where is my game set game? Here it is. Same thing for the scene chunk generation, scan position. And with this, we should now have the problem corrected. Yep, and we'll have to see what we do here with the void awake in a second. But let's first look at if this works or not. So only when the game is running should we be able to scan the position. So let's see if that behavior is in work. Yep, so as you can see, things despawn. And if I want to run into the wall, we can still call the reset, and reset work just well, as you can see. And we're back to normal, except the fact that we spawn on the wrong lane. So it's something we'll also have to fix in a second. But the behavior we wanted is there. So everything is working as intended with this. And also we save a couple of CPU cycle because every single frame, we had two scripts running scan position prior, and now we only have them running scan position when they are when we are in a game state game. Now, in terms of reset world, I actually think that we should no longer have this code marked as to delete for the sole purpose that when I began writing this tutorial, I had a different logic go around this, but it seems that every time I re-record something that I've done in the past, I always go and do a little bit of touches, incremental touches to the code that makes it look a little bit better or is a little bit more understandable. So having it on the wake makes a lot of sense with the new implementation I've done. Now, obviously, I can't show the old one, but this is no longer a piece of code that I want to get rid of. Actually, it works very well without. If you're curious, before that, I had the scene chunk generation, also the world generation in the same script, and it was a real mess. So I've changed that to just have the scene chunk generation be a inherit from the world. Okay, so our last problem is the fact that I started in the wrong lane all the time when I was respawning. So for example here, I die, respawn, and it goes back to the lane I was. So that's a very, very simple fix. We are simply going to reset our current lane when we do die. So going back under the game state def, here I do reset player. On the reset player, I'm also going to set current lane is equal to 0. Do remember, I am in the player motor.cs right now. And I believe that is what we need to do to wrap up this section, the game flow section, and we will have a complete game flow. Yep, so the game flow is complete, and it's a very, very nice milestone for a game. It's a very nice, it's a good milestone for a game. You guys can be proud of yourself. We've made something that you can play and just, start over again and play. And it just doesn't have any sense of progression right now, but at least you have a full loop. And yeah, that's amazing. Okay, so I'm very happy we're done with this part. In the next one, we can start laying down a little bit of the UI to make this more navigation friendly and make this more user friendly. Once that next section with the UI is completed, we are going to head into shop logic, saving data, collectible, and we're going to look to wrap the game up after that. So thank you so much for watching this section, and I will